Hi guys! This question was taken from a 2003 NJML contest. Calculators are allowed as long as they don't have a QWERTY keyboard. Let's get started. The question is, what are all values of x that satisfy the inequality log base x of 5 is greater than log base x of 10? Pause the video, give it a try, and come back when you think you know the answer. Before I start going over my solution, I'm going to give a hint. The hint is, first try to isolate the variable x, and then try to find out all the possible values it can take on. Anyways, I'm going to dive into my solution. The first step is, let's combine both these terms, the term on the left side and the term on the right side, and by doing so, we'll end up with only one variable x. Since the variable will be isolated, it will be easier to solve for all possible values of x. Subtract log base x of 10 from both sides of the inequality. Doing so results in the inequality shown here. The next step is to realize that since both log terms have the same base, so it's x in both cases, we can apply this log rule right over here. And this would result in the following inequality. So now we ended up with this inequality, which has only one x term. Since we know that 1/2 simply equals 2 to the power of -1, we can rewrite this inequality as follows. Now, if we apply another log rule, which involves exponents, we end up with this. Multiplying both sides by -1 results in the left side becoming positive, the right side still staying 0, since 0 times -1 is still 0. And remember, whenever you multiply an inequality by a negative number, the sign in the middle also changes, so the greater than sign now becomes less than. Now we end up with a pretty simple log inequality. To figure out all of the values of x that satisfy this inequality, all we have to do is graph this equation here and figure out all of the values of x that make y negative. We can quickly sketch a graph of this equation by choosing a few critical values for x and seeing what the y values are. So for instance, when x equals 2, y equals 1. When x equals 1, well, in that case, this equation turns into 1 to the power of y equals 2. And that doesn't make much sense because 1 to anything will always be 1. So this will never happen. Therefore, there's actually a vertical asymptote at x equals 1. When x is 0, this equation turns into 0 to the power of y equals 2, which once again doesn't make much sense. So there's a vertical asymptote at x equals 0. When x equals 1/2, y equals -1, since 1/2 to the power of -1 gives you 2. When x equals 1/4, y equals -1/2, since 1/4 to the power of -1/2 gives us 2. When x equals 4, y equals 1/2. When x equals 8, y equals 1/3. Let's just plot the few points we've gathered in this table here and see how the graph looks like. As seen in the graph, the values of x for which y is negative is whenever x is between 0 or 1. But remember, it doesn't include 0 or 1 because at 0 and 1, y is undefined. So our answer is x is greater than 0 but less than 1. Bye guys, see you in my next video.